Is he ready? Are you ready?
Yeah, I'm ready. Are you all ready?
Woo! He's so happy. Hi,
right.
TypeScript for JavaScripties. Go, Joshi.
Thank you very much. Hey, everyone. This is going to be high energy because this is exciting stuff. We all learned about AI and unit testing, and now let's learn about language theory and static analysis. Oh, my thingy. Please work. Please. No, it was doing so well earlier. Do I get the clicker? Please, a click. Yes. No. That's. Okay. All right. I'm already hyperventilating, and we haven't even talked about TypeScript. All right. Hi, everyone. Whew. Now we begin. Thanks for having me. Thank you for the excellent introduction. Thank you, City.js. This city is wonderful, and I'm having a great time. I'm Josh Goldberg. I'm a full-time independent open source maintainer working in the TypeScript ecosystem. Has anyone here used TypeScript? Yes, love to see it. I also wrote a book about TypeScript. Just curious, has anyone here read or purchased my book? I'm expecting very few hands. Thank you, a few of you. Awesome. Learning TypeScript. I really like cats. Where's Mariah? Mariah's right there. She got me into the cats. It's her fault. Also, if anyone wants to go on a run with me at some point, that would be really nice. No one has wanted to run. One person, thank you, wanted an evening run, which I might be too exhausted. Anyway, talking about TypeScript is hard because there was a lot of hand raising going on, and so many of you already know TypeScript. So now I'm in this weird, awkward situation where I have to explain TypeScript to the new people in an interesting, entertaining way. And I have to make it appealing to the folks who already know this. They already have opinions. So I'm going to do my best. And I'm going to say if you're new, this will be a hopefully good introduction. And if you already know TypeScript, well, maybe this will be a new way of thinking about things or a new way of explaining stuff. Because if you know TypeScript, I hope a significant part of your day is going out and screaming at people on the street about how good TypeScript is. So maybe this will be useful. Are we ready to go? Yes! Woo! All right. TypeScript. Why won't Tech Twitter, soon to be Tech Blue Sky or whatever, shut up about it? So TypeScript is a superset of JavaScript. That is the technical definition. That doesn't mean anything to a lot of people, so a lot of us advertise it as JavaScript with types, which is like kind of imprecise. So I'm going to give you my personal explanation for why we have this thing. JavaScript has a flaw. It only describes your code's values. With any language that doesn't have a built-in type syntax, you don't have a way to explain what something's intent is. The word intent is key here. You can say that you have a variable, let my value, but you can't say what's supposed to go in it, what it's supposed to be used for, how it's supposed to be used. TypeScript gives you a documentation form, the little type annotations here, that lets you say at the very least what's supposed to be inside of it, what its data shape or size is supposed to be. Oh, wait, with the clicker. All right. So this is a little quintessential example of why TypeScript is great. Without type checking, we have no way of knowing whether this little component written in whatever JSX syntax library you prefer is good and correct and being used properly. We have no way of knowing whether this break the internet component is using it properly. We don't know. We have no way of knowing, just looking at the latter thing, whether it's using the former right. We don't know if my button is allowed to not take an on-click. There we go. We don't know whether it's allowed to take in a string for the on-click. I don't know whether the clicker is going to work. Maybe we'll guess right and say that the on-click prop is right. Maybe we get it wrong and call it on-tap instead of on-click. It's mysterious to us. And we can try our code out at runtime and get to the point where the stuff is rendered or whatever, but that's a pain. TypeScript gives us a way to verify statically, without running our code, whether something is correct. Yay. I'm giving up on the clicker. It's never worked and it's never going to work. So TypeScript is four things. Technically speaking, TypeScript describes the programming language. It is the language that contains all the existing JavaScript syntax you know and love, plus a bunch of type-specific stuff. On top of that, the word TypeScript also means the type checker, which is a program written in TypeScript that reads in your source files, your .js, .ts, whatever, and then lets you know if there are likely bugs or mishaps, mismatches in those files. TypeScript, the term, also could mean the compiler, another program written in TypeScript that runs the type checker and transpiles your code from the original TypeScript syntax out to the output JavaScript. TypeScript, the term, also could mean the language service, which is yet another program written in TypeScript. Yeah, that runs inside your editor, your IDE, such as VS Code, and then gives you the little red squigglies and refactors and stuff that we'll look at later. Awesome. So if you want to, I won't be offended if you're on your laptop the whole time. You can go to typescriptlang.org/play, try it out. On the left of the screen will be a nice editor where you can type in TypeScript, and on the right will be a view of the resultant JavaScript or angry red squiggly errors. In goes TypeScript, out comes JavaScript. And with that, it's a whole new world I've introduced you to. I encourage you to explore. It's going to be great. But I also want to walk you through some of the basics of what you'll see in that playground. So TypeScript. What does TypeScript know? Does it know things? Let's find out! Woo! TypeScript, this has a type system. The type system is the core to everything we're going to talk about today. The theory of a type system is a programmer idea that looks at your source code and understands how every value is supposed to be used. What types, what shape of data is supposed to be in every value. And when I say value, I can mean any construct in code. I mean runtime values, and I also can mean types, which we call type objects or interfaces. So whenever you declare a construct like a class, a variable, a function, an interface, whatever, TypeScript memorizes what its type is allowed to be. And later on, if you use that type, that construct, that whatever, in a way that mismatches with the type, you get the red squiggly, the complaint. I'm a hopeful person, so maybe, there we go. Cool. Our first red squiggly, yay! If we declare a variable named Aris, and then based on some 50-50 probability, we say Aris rules, which is true. Where did he go? Can't see anything in these. That's great. But if we had previously declared the variable to be a string, and then put a number in the variable, TypeScript's mad. Wow, that font contrast is really good. It says type number is not assignable to type string. That's an example of us declaring one thing, and then the type system letting us know when it's mismatched. Sound reasonable so far? Yeah! I will accept sullen nods. Thank you. Cool. TypeScript actually has a pretty advanced, unique type system relative to a lot of the languages we are used to that are older than 5 years, 10 years. TypeScript has the concept of a union type, something that could be one of potentially 2 or more types. Like here we have the variable which is either Athens, a string, or the number, 1337. So TypeScript knows that, as you can barely see at the end of the error message, this thing isn't just string or just number. It is string or number, string union pipe number. So you're allowed to do things with that work on either of those types, because if you call .toString, that'll work regardless of whether it's a string or number. But if you call toUppercase, no, because that only exists on string. So you have a 50-50 chance of your code crashing. Do not want. And if you want to really get specific and fancy with your types, you can annotate them ahead of time. Here we can say that my value is only ever going to be a string. And this is our first real example of TypeScript-specific type syntax, :string. We are telling TypeScript that later on, I'm only ever going to put a string here. So if I put a number, yell at me. That's not allowed. And I mentioned earlier there's transpilation, the compiler. When this gets turned into JavaScript, that type annotation goes away. It's not a JavaScript thing. Fun fact, there is actually a proposal to add a syntax for type annotations to the JavaScript language. There will be years until that beautiful thing is ratified. So don't worry about it. Cool. So I think TypeScript is pretty cool. And I want to start exploring some of the more cool parts of it. Like an 80s biker cop over here. It's cool, and one of the key concepts that I want to really hone in on is that TypeScript lets you develop better. It gives you awesome insights into your code. It gives you cool refactoring things. It'll spot bugs for you. And an analogy that I like to make is that writing TypeScript after writing JavaScript is like taking off sunglasses when you're inside. There's no need for us to restrict ourselves that way. They were like $10, don't worry. You thought I was being weird. I was. All right. because TypeScript makes us happy. Yay. All right. So unions and literals. We talked about unions a little bit, which is a feature not unique to TypeScript, but unique to, I think, a lot of newer languages, also some fancy old functional languages. And type narrowing. Let's go into these terms. OK, so we can annotate union types. You can annotate any type, string or number. So saying something is string or number means it'll only ever be a string or a number. Anyone here tried Moussaka yet, if you're not native to this area? Freaking love that stuff. It's so good. Yay! If you try to assign a Boolean to your string or number, that's not allowed. TypeScript has the concept of type narrowing, where if we have something that's only ever, let's say, a number or string, we're not allowed to call to uppercase. But TypeScript recognizes that if there is an area of your code that can only ever be hit, if the variable is a particular type, then inside that area, TypeScript will narrow the type to the stuff that it figured it can only possibly be. Inside this if statement, we say if type of value is string, then do value.toUppercase. And of course, TypeScript should allow that. We know inside that if statement, value is a string. Narrowing. The opposite would be widening, which is a whole other can of worms. My God, I'm so much less smooth than I normally am. All right. TypeScript also has another really cool feature, literal values. I learned this. I asked ChatGPT for 20 examples of homonyms and homophones in Greek, and none of them were valid, except for this one. Apparently, I forget which is which, euphoria and ephoria. One is euphoria in English, the other is tax office. Very different, let me tell you, as an independent consultant. Euphoria, the string, is the only allowed value for this variable. Now, I'm not saying it can be any old string. I'm saying it can specifically only be that string, which I think is euphoria. So if you assign another string to it, it might also be a string, but it's not the specific string we want. The string primitive is one area, and you can consider the primitive type string to be a union of all the possible literals of that string. Empty string, or A, or B, or C, or Greek letters, and so on. This is really cool. Take that, C#. Great language, by the way. Love C#. So literals actually are useful beyond just making jokes about taxes. A lot of the times you'll see values that have them in union types. For example, string or -1 is a common one you might see, where you can be a string or a -1 to indicate it's not right. And all the principles we've seen so far around narrowing work. You can't assign the number 1337, but if you were to check if type of thing is string, then you would be able to narrow it down to a string and then narrow your usage. Cool. All right. So there's another thing. Anyone here heard of the billion-dollar mistake in industry? No? All right, so the idea of allowing things that are null, or in JavaScript, undefined alternately, to places that don't explicitly say they allow null or undefined has widely been considered a mistake in programming languages because it's confusing as heck. In TypeScript, there's a compiler option to enable it. So saying that value, oh yeah, here we go. Value is string or undefined means that you can't assign undefined to it. I thought I put value equals null in there, but I guess I was wrong. Oh well. Slide's a mistake. Cool. So we've come a long way. We've talked about literals and narrowing and stuff. I'm already losing you. Let's talk about objects, because everyone loves JavaScript objects. Object types are understood by TypeScript. It'd be a really useless language if it didn't. If you create a value, it is going to start off with a type equivalent to that object type. Value equals name Josh, power 9001. You can do value.name, value.power. You can't assign or access new properties because they're known to not exist. And you can use these in object type annotations as well. The object type annotation looks like an object, but with the types instead of the values. So if you say value equals name and power, that's allowed. Value equals just name. Oh no, you missed power. I don't show it in this presentation, but there are ways to indicate that properties are optional or only conditionally exist or all sorts of wild and wacky crap, most of which you don't want to use. There we go. And just as a quick little syntax tip, there are object type aliases in TypeScript. This little type feature allows you to kind of copy and paste types. So here, whenever we say name and power, what we actually mean is the object containing name string, power number. Cool. I want to show you one last really nice syntax feature, and I'm going to have to go to the laptop for this. Anyone here used a discriminated type union or an algebraic data type? Almost no hands. Very excited about this. So let's combine all these things. Let's say that we have a type success result equals value string, happy, true, and type failure result equals error, error, happy, false. And let's say const my result, success result or failure result equals math random greater than 0.5, value yay, happy, true, or error, new error, happy, false. All right. So here we're saying that my result is either a success or a failure. And I'm going to quickly say either results, more on that little thing I just did later. So I can't access my result.value or error because TypeScript knows either of them might not exist. And happy is true or false, which is Boolean. But if I do if my result.happy, then I can do my result.value string. What? This is actually really cool. I realize it's like a very plain, straightforward demo. But imagine the possibilities where if you type your fetch wrapper or whatever to only ever expose the data if there was a result.ok and otherwise force people to access the error. This is a very powerful type system feature that I would encourage you to try to play around with. Cool stuff. I'm running short on time, so I'm just going to keep going. All right, so hooray, question mark. This is cool stuff. It might not seem immediately applicable, but I love it. It's really cool. And come talk to me after the conference talks if you want to nerd out about typing together. I got two more things I want to show you. And the general theme here is that type information improves tooling throughout the development process. It's not just the language that you're writing in. And one would say that type information is like a high five. Yeah! Woo! Amongst all your tools. And I'm going to show you two examples of this. Thank you so much, Sergio. That was awesome. Using IDE features. So I'm just going to quickly go back to this stuff. We've got this function, options, greet options, as this greet function. And you know what? I want to extract these to a new file. So I'm just going to move to a new file. And I guess the file already exists. So I'm going to go over here. And you know what? This thing isn't greet options. I want to call it great options. Yay! Going to rename that. And notice, by the way, this is not just some sort of silly find and replace. This is actually going through and finding all the places that the thing is used in code and renaming them. So that if you were to right-click and find all references, TypeScript is smart enough to see that the type exists in all these places. And if I were to go to my VS Code Explorer and rename this file to yippee, TypeScript knows to automatically update the source import here, this beautiful combination of the TypeScript language server and VS Code. And all this is possible because TypeScript generates a type system understanding of your code. Very cool stuff. No more code demos, just slides. A little recap for the online audience. Does anyone here lint their TypeScript code? So much less enthusiasm. Oh, I suppose I have to. Thank you. So I work on TypeScript ESLint. I'm one of the core maintainers. It's the tool that lets you run linters like ESLint and formatters like Prettier on TypeScript. And TypeScript introduces a cool new thing in the linting model. Because prior to type systems in JavaScript, there were really three major ways of doing static analysis on your code, ranging in the fast ones to the slow, powerful ones. On the speed side, you have formatters like Prettier. Yes, love Prettier. And then you also have type checkers that are now being introduced, and traditional linters like ESLint. But if you were to use the type information from TypeScript in a traditional linter, you would get this new fancy, powerful thing that uses the type information in lint rules to make really advanced deductions on your code. So I'm going to go over what I mean by that. Let's say that you have an await console.log. Does anyone know what happens if you await something in JavaScript that isn't a promise? You just get the thing back. Nothing happens. So it's totally unnecessary to await the result of console.log. And we have a rule in TypeScript ESLint, the await venable rule. Does anyone use it? No one uses it? Okay, I'm fine. Where it would yell at you saying, aha, you fool, Josh. You can't even use a clicker. Unexpected await of a non-promise, non-venable value. And even better, the rule would offer to fix your code for you, getting rid of that await, and telling you you're a smart person, good for you. Now, this is a toy example. I don't think any of you have ever written await console.log. But imagine if you have some complicated crap that someone else wrote 12 months ago, and you're a murderous psychopath who knows where they live, and you need to fix that code. And you don't even know React. You're a Vue developer. This JSX crap is terrible for you. So, fun fact, there's a bug, sort of, in here. You look at the code, and you would run await venable on it. My God. And await venable would, point out that await on click, because that's not necessary, because on click is a function that returns void. Using syntax that I didn't even teach you yet, you might not even know how to represent function syntax. So await venable, well, one option is to change the onClick to say it returns a promise. That's valid. But what if the onClick isn't allowed to be synchronous or asynchronous? What if it must be synchronous? Well, await venable would have then told you to remove the await, which then means that this running state is useless. It's always just immediately false, which means that the onClick and disable function is useless, which means that the running state is useless, which means that this whole button disable thing is useless, which means that we were able to refactor-ish our code down from 1.5x the results to 1x the results using the power of static analysis. Yay for us! Woo! Awesome. Thank you for your enthusiasm. Hell yeah. I forgot to ask if I was allowed to swear before this. Good place. All right, so some closing thoughts. All the things I mentioned are available for resourcing online. TypeScriptLine.org is a very good set of docs. TypeScriptLine.org/play, in goes TypeScript, out comes JavaScript. The linter tool that I work on, TypeScript ESLint, the tooling that allows you to run ESLint and prettier on TypeScript code. TypeScript-ESLint.io. It's all open source. Would love any of your feedback. And then I mentioned I wrote a book. I think it's a pretty good book. LearningTypeScript.com, published through O'Reilly. It is a sun conure on the cover. Before you all ask me about the animal, I did not have a say, but I'm very pleased with the results. All right. So TypeScript ESLint is an open source project. We're independent, so please file bugs, use us, let us know how it goes. Even just documentation complaints are useful. And of course, please give us money because we're not associated with any company. You can buy my book and support me personally because I'm an independent open source person. And last request, this is the first time I'm asking this at the end of a talk. I never get any constructive feedback. It's real pain. It makes it hard for me to grow. So please scream at me in any way, shape, or form how I can make this better. If you think I suck and you hate me, just let me know. I'll handle it okay. With all that being said, thank you again, CityJS Athens. This was wonderful. Cheers, y'all.